Okay, it is that time of the morning, so I'm going to go ahead and get started. The very first thing I wanted to make note of is that your Chem 101 attendance code is 1513, and right now only 11 students out of 56 have signed in. You have about 10 minutes to get signed in. Now it's up to 14. But some very quick announcements. The first announcement is that your measurements, data, results, and post lab from basically the information from last week is due tonight by 11:59 p.m. You will be completing the Google form that was in last week's folder in the laboratory materials folder. There are 3 ed puzzles related to density that is due tonight by 11:59 p.m. Those will be found in this week's folder, laboratory materials folder, ed puzzles folder. Somehow I missed, until somebody made note of it, I missed getting the Chem 101 homework 2 to go live. It is now live. And then the other another comment is the density lab for tomorrow. Or we will be performing the density lab tomorrow, and you will come in at the exact same time as you did last week. So again, half of you will come in at the start of your scheduled lab, the other half will come in an hour and 20 minutes into that time. Number 5 up there, study session. Today we're supposed to have a study session. I believe it's from 2 to 3:30. I hope to be able to have the study session. I've got somebody coming out to my house to do some maintenance, and so when they call, I may have to leave. So keep an eye on Blackboard and on your email. If for some reason I do have to cancel the study session, I will let you know. Then the last thing I wanted to make note of, quiz number 1, where you actually have to turn it in my office, is due on Monday of next week. So keep that in mind. It's coming up.
Dr. Yarberry,
Yes.
how do we find your office again?
Okay, so if you're on campus and you find Mannion Hall, if you're looking towards the library from Mannion Hall's front door, and you look to the left, you'll see a bike rack. That bike rack is on the sidewalk that leads into my office area. So you just basically follow that sidewalk right into the building, and there's only like 6, 7 offices in here, so it's easy to find once you get in here.
Dr. Yarberry,
Yes.
I couldn't get on to the GroupMe because the link didn't work.
That's interesting, because for some it did, and then you say it didn't work for you.
Right, it said it couldn't connect.
That's bizarre.
It's the same thing for me too.
That happened for me as well.
Me too.
Me too.
Okay, so let me see if I can remedy that real quick. That one. Trying to see, I know I can do this. Okay, if everybody can, what I'm going to do is I'm going to share my screen. I have created a QR code that you can use with any cell phone camera. Maybe that would work.
That worked.
Looks like it's working. Okay. I will try to, and I'm trying to keep up with everybody as always. So, okay. Again, if you need that QR code, I'll give another minute for those that didn't get it the first time. Okay. Okay, and let me get back to the other document now. The code is 1513. And there's still 4 minutes to go on that for those that have not signed in. Okay, any other questions about general information? I am trying to keep up to the best of my ability here. Okay, if there are no other question, so when is the lab due? Is a question that I did receive in chat. The measurements lab is due tonight. The density lab, the data results and stuff won't be due until till next Wednesday. So basically the results, the data, the results, and any post lab questions are always due the Wednesday after we complete the lab. Okay, so another question I got is how do you get to the attendance? You should be able to log into Chem 101 and you should see something that says attendance. And you simply click on that. And it'll ask for the code. At this point, I am still comparing it to Zoom, but I won't be doing that for much longer. Okay, so today we are actually getting into conversions. And everybody has their own process for performing conversions. You don't have to follow my exact process. What I am describing in these steps that I'm showing you is the process though that I use. And so I wanted to at least discuss those steps so that you are familiar with my process, since you'll see it on and off all semester long. So the very first thing I do is I'm going to make a list of the information that is given. And when I'm making that list of information given, if there is a substance attached to a piece of information, such as ampicillin or sodium chloride, I will even, as I'm making the list of information, I'll also include the substance as part of the unit. Then from the list of information that I make, I'm going to identify the piece of information that I'm going to use to start the calculation. Most of the time, I always try, now it's not always possible, but I always try to start a calculation with a piece of information that has only one unit attached to it. After that, I start to identify possible conversion factors. Now, folks, yes, I have a lot of experience, so most of the time I can identify many of the conversion factors that I'm going to need to start with. but I might not get them all right off the bat. Because of the way I approach a conversion, however, I can identify when I do not have a conversion factor that I may still need. And I'll do more of that as we go. Now, when I am looking at possible conversion factors, one of the things that I pay attention to is, does the starting unit and the ending unit contain the same phrase? If the starting unit and the ending unit do contain the same phrase, then that means you're going to need your metric prefix conversion factors, which you have to have memorized. Those are the only conversion factors I am making you memorize. That, and there's one other besides those that you'll need to know, and that is one that's extremely important from a pharmaceutical perspective, and that is 1 centimeter cubed is equal to a milliliter. Now, as I'm going through these and identifying possible conversion factors, if my starting unit and ending unit do not have anything in common, then that means I'm going to need my English to metric conversion table, which you would be given, or I need to look into the problem and see if there's a conversion factor in the problem that I can use. So after that, I start to line up my conversions. I start with the quantity that I've identified as my start in step 2. I start with that quantity, and then each successive conversion factor is set up so that the numerator in a previous conversion factor is canceled out by the denominator in the next conversion factor as much as possible. And then you perform your calculation and you record your answer. Now, today, my goal is not to spend a lot of time on talking any more than I've already spent. We're doing nothing but problems for the rest of class, so that hopefully you have several you can refer to when you're doing the homework. Any questions thus far? So let's just start out with something very similar to what you would see on the optional homework for the first like 2 pages. 0.587 liters is equal to how many milliliters? The first thing I notice is that this has something in common. So it's going to be a metric prefix conversion factor that I'm going to need. Now, depending upon whether you're looking at the table that I gave you or whether it's something you're familiar with, there are 2 ways to write the conversion factor for this particular conversion. One possible way is that 1 liter is equal to 1,000 milliliters, or 1 times 10 to the minus 3 liters is equal to 1 milliliter. The second one is the one that I gave you, but basically to get to the second one, you simply rearrange the first one. Now that we've identified a possible conversion factor, we're simply ready to do this, to start with it. So the 0.587 liters. The liters are currently in the numerator. In order to get rid of them, I'm going to need to put the liter portion into the denominator and the milliliters in the numerator. And we do that so that the unit will cancel out. When you complete this calculation, you get 587 milliliters. As far as significant digits are concerned, this one had 3 significant figures And your metric prefix conversion factors are exact quantities with unlimited number of significant digits. Since this is multiplication and division, your answer will have the same number of significant digits as the measurement with the fewest. So our answer needed to have only 3 significant digits. And so if we're focusing on significant digits, 587 milliliters would be correct.
Dr. Y,
Yes.
is it 1 times 10 to the negative 3 or 1 times 10 to positive 3?
1 times 10 to the negative 3 liters is equal to 1 milliliter. So it all depends upon where it's attached. In this case, it's a negative 3 because it's associated with the liters.
Thank you.
Mhm. Let's look at another example. A strand of spider silk has a diameter of 3.50 micrometers. The funky U is the unit for micro. And I didn't finish this out, so we're going to go with how wide is the spider silk in millimeters? Now, what I notice is that my units have something in common. So again, that means I'm going to use the metric prefix conversion factors. When I look up the metric prefix conversion factors that I've asked you to memorize, you would find that 1 times 10 to the minus 6 meters is equal to 1 micrometer. And you would find that 1 times 10 to the minus 3 meters is equal to 1 millimeter. Folks, one of the reasons I gave you the metric prefix conversion factors that I did is because if you pay attention to the way that I have written the metric prefix conversion factors back last week, the 1 was always associated with the prefix unit. And the scientific notation was always associated with the base unit. So it helps you to keep them straight. Again, if you use the table I gave you last week, the table that is also found in the units PowerPoint, you will see that the way I always write it is so that the 1 is attached to the prefix unit and the scientific notation is always attached to the base unit. Okay, so let's begin this calculation. We're going to start with the 3.50 micrometers. I need a conversion factor that contains micrometers. The conversion factor I will use is going to be this first one. In doing so, my micrometer piece needs to go into the denominator with the 1 times 10 to the negative 6 meters in the numerator. We place the micrometers in the denominator so that the unit will cancel. And I am left with meters. Now I'm going to go to my other conversion factor that has meters. Once you use one conversion factor, you don't use that one again. So I got to go to another one that has the meters in it. In this case, the meter portion will go into the denominator. The meter portion had to go in the denominator so that the unit would cancel out. And I've got it to millimeters, which is what I asked you to solve for. So now I can key it into the calculator. And when I key this into the calculator, I get 0.0035 millimeters, or in other words, 3.5 times 10 to the minus 3 millimeters. Now, I do have to be careful if I'm thinking about significant digits. My very first value has 3 significant digits because zeros at the end of the number after the decimal are significant. Scientific notation conversion factors are exact quantities, so they have unlimited numbers of significant digits. So both of my conversion factors were exact quantities with unlimited numbers of significant digits. This is multiplication and division. According to multiplication and division, your answer has to have the same number of significant digits as the measurement with the fewest. So my answer should have 3 significant digits in it. So if I'm doing this by significant digits, I should record my answer as either 0.00350 millimeters or 3.50 times 10 to the minus 3 millimeters. Questions about that one?
Whenever we're doing conversion factors, are we always going to do significant figures for the final answer?
No, there's only 3 problems on your first exam and 3 problems on the final where I will require you to pay attention to significant digits. Otherwise, besides the first exam and the final exam, the only other time I'm going to make you pay attention to significant digits is in the laboratory. So in the laboratory, if you perform conversions, yes, you have to pay attention to significant digits. Okay, let's look at another one. An athlete is preparing for a marathon and runs 21.3 miles. How many kilometers did they run? You will notice nothing is in common here. So that means that I am either going to look to the problem or I am going to look to an English to metric conversion table. And when I look to an English to metric table, one of my possibilities is that 1 mile is equal to, whoops. Let me find a good table. There are a gazillion tables out there, so it's just a matter of finding one I like. One possible conversion factor is that 1 mile is equal to 1.609 kilometers. So I now start with the 21.3 miles. With my conversion factor, the mile portion will need to go into the denominator. The kilometers in the numerator, the mile had to go in the denominator. so that the units would cancel out and I would be left with the desired unit of kilometers. And when you key this into the calculator, you get 34.2717 kilometers. Now, with respect to our conversion factors, our significant digits, we have 3 significant digits in our first measurement. And then as far as English to metric, you do have to pay attention to significant digits. There are 4 significant digits in the numerator, and then the 1 portion of a English to metric is going to be an exact quantity. So therefore, there were 4 sig figs in the numerator and exact unlimited in the denominator. This is multiplication and division. Your answer will have the same number of significant digits as the measurement with fewest. So your answer should have 3. So if we were recording this to the correct number of significant digits, we would record it as 34.3 kilometers. Any questions? Let's take and get a little bit more challenging. Or potentially more challenging. Let's get into some dosage calculations. I know a lot of people in my classes tend to want to go into pharmacy or into med school. So let's talk about some dosages. A patient needs 25.0 micrograms of Synthroid. The pharmacy only has Synthroid that is 0.025 milligrams per tablet. How many tablets should be taken each day by the patient? So listing out what we have 25.0 micrograms, and we have 0.025 milligrams of Synthroid per 1 tablet. Now, I'm going to identify which of these pieces of information I want to start with. Again, it is ideal, if possible, to start a conversion with something that has only 1 unit associated with it. Since the micrograms of Synthroid has only 1 unit associated with it, that is where we're going to begin our calculation. And we will be converting that into tablets. Now, we need to identify possible conversion factors. Synthroid and tablets. We have 2 different substances. So, look to the problem to find conversion factor. So we will be using this as a conversion factor because it has both substances in it. Now, the next thing I notice is we have micrograms and milligrams of Synthroid. So that tells me I'm going to need my metric conversion factors as well. So the microgram conversion factor again is 1 times 10 to the minus 6 grams is equal to a microgram. And the milligram conversion factor is 1 times 10 to the minus 3 grams would be equal to 1 milligram. So basically, what I do, folks, is once I've identified what I want to start with and what I'm solving for, you'll notice I basically took it and broke it down. Two different substances, look to problem for conversion factor. Then different units, look to tables for conversion factors. So now to begin this problem, we have the 25.0 micrograms. Our first task is going to be to use something with micrograms in it. So we're going to use the metric prefix conversion factor. The microgram portion of the metric prefix conversion factor is going to go into the denominator so that the units will cancel and you're left with grams. Next, we need to convert our grams to milligrams so that we can ultimately use the conversion factor we were given. So we go from grams to milligrams. So the gram portion of the metric prefix conversion factor goes into the denominator and the milligram portion in the numerator. The gram portion went into the denominator so that the units would cancel. And we're left with milligrams. Now that we have it in a unit that is in the conversion factor we were given, we can apply it. But here's the deal. You'll notice that currently milligrams is in the numerator. So in order for it to cancel, we need milligrams in the denominator. So we're going to flip our information that was given to us in the problem. And the 0.025 milligrams of Synthroid will go in the denominator and the 1 tablet in the numerator. We had to put those milligrams in the denominator so that the units would cancel. So you have 25 times 1 to the -6 divided by 1 to the -3 divided by 0.025, and our answer comes out to be, did I just do that right? Our answer comes out to be 1. Now, if we're looking at significant digits, our starting quantity had 3 significant digits. Scientific, your metric prefix are exact quantities with unlimited number of significant digits. So your next 2 conversion factors have unlimited number of significant digits. The single tablet, the 1 is an exact quantity and the denominator had 2 significant digits. Since this is multiplication and division, your answer should have the same number of significant digits as the measurement with the fewest. So we would expect it to have 2, so we would write it as 1.0 tablets. Questions about that one? Let's look at another one. A patient weighing 185 pounds is prescribed a 10% IV immunoglobulin solution for primary immunodeficiency. Okay, one of the reasons I pulled this one in is because I want to explain percentages real quick. This is a unit of concentration. And percentages can be in the form of either mass percentages or volume percentages. There's also mass volume, but they're less common. Now, in this particular case, I kind of glanced through the rest of the problem. And what I noticed is in the rest of the problem, it's always talking about mass. So we're going to use mass. Now that 10% literally means 10.0 grams, and we're going to shorten that phlebigamma immunoglobulin as to Ig. That's 10 grams of the Ig to 100 grams of solution. Okay, then we move on. We see, then it talks about, let's see, the recommended dose is 300.0 milligrams Ig per 1 kilogram body mass. And then it goes on, assuming a maximum infusion rate of 5.00 milligrams. And that would be of solution per milligrams, excuse me, per kilogram per minute. How many hours will it take to administer the original, the recommended dose? Okay, on this particular one, this is my starting quantity because it had only 1 unit associated with it. That's where I'm going to start this calculation because it has only 1 unit associated with it. So we have the 185.0 pounds of body mass. Our first conversion factor is going to need body mass. But looking at my conversion factors that have body mass, I need that to be in kilograms. So I don't have all my conversion factors. That's what I was trying to tell you. You may or may not get all your conversion factors, but if you're following your units, you will ultimately get it. And what I see when I go find a conversion factor is that 1 pound is equal to 0.454 kilograms. Now I have another conversion factor. So I'm going to put the pound piece in the denominator and the kilogram piece in the numerator. I did that so that my unit and substance would cancel out. And I'm left with kilograms, and that would be kilograms of body mass at this point. Now I can use the conversion factor that had body mass to begin with, and that would be 300.0 milligrams of Ig is 1 kilogram of body mass. The kilogram portion had to go in the denominator so that the unit and the substance would cancel out, and I'm left with 300 milligrams of Ig. Now I want to use my 10% solution. But in order to be able to do that, I've got to get that milligrams of Ig into grams of Ig. So again, I didn't have all my conversion factors. So I went and found another one. So there's of that one though, the 1,000 milligrams of IG will go into the denominator to 1 gram of IG. And then I've got my, now I can use this percentage to convert the IG into solution. So that the IG will cancel out, leaving me my grams of solution, which I've got solution over here. It's in a slightly different quantity, but this is how I get to my minutes at this point. And basically, a milligram per kilogram per minute. That is the infusion rate. Is you have the milligram IG per kilogram of solution per minute. And even folks, even me, you know, I've been doing this a long time. I didn't do these calculations and to begin with on purpose. I actually wanted to wait and do them with you, because you will find even with a professor, I'm looking at this and I'm like, wait a second. I actually didn't even need the concentration. I did not need this piece. I only needed this piece of the information.
I had a question on the 1 gram IG and the 1,000 milligram. Couldn't you have solved that using like the 10 to the -3 instead?
Yes, I could have flipped the, if I had a 10 to the -3, then it would have been, the 10 to the -3 would have been with the gram is the difference. So it's all whether it's with the milligram or with the gram. So folks, basically looking at this, notice I got milligram per kilogram right there. I can stop. This is my entire point. I wanted to demonstrate. Even if you know what you're doing on conversions, there are going to be times where it is a puzzle. And I can actually go back to this step right here, solve. And right now I have 25,197 milligram IG per kilogram body weight. That I can then use in the next part of the problem. Because I can then use the other conversion factor to get it into minutes. And then there would be 60 minutes in an hour because I did want hours. And it comes out to be 83.99 hours, which if I'm doing my conversion factors, I would record it as 84.0 hours with the conversion factors I have here. So let me just go back a moment. You are not going to always know exactly the conversion factors. There are going to be extra things, but if you're following your units, the entire reason I knew I made a mistake, the entire reason I knew I made a mistake is because my only conversion factor that had time in it needed milligrams per kilogram, and I didn't have that. If you follow your units, you will know if you have a mistake. If you do not pay attention to units, folks, I can guarantee you are going to struggle with a conversion. You have to pay attention to your units. I want to see units. Now, really quickly, because I don't have, I'm not going to make it to my last, I had 2 more problems to do. I'm not going to make it to those just yet, but I want to show you something in case you start Chem 101. I want to show you a type of problem that you will encounter and what it means. So one type of problem that you, well, here's the spider silk one that we did. When you get into the problems, they're going to make you write them out just like we did on our sheet. So I did the spider silk one with you. So we had our 3.50 micrometers as our starting quantity. Our first conversion factor was 1 times 10 to the minus 6. Let's see. 10 to the minus 6 meters is 1 micrometer. Then you can add a factor, and our next factor was 1 millimeter. Oh, that was supposed to be nanometer. Okay, so they wanted in nanometers. So 1 nanometer would have been 10 to the minus 9 meters. And then you would get your answer, which in this case, because I did change it up slightly, is 3,500. So 3.50 to the third nanometers. And then you can show your answer. So in other words, it's going to make you put in all those steps. And I wanted to demonstrate how it works. Notice they don't have 1 times 10 to the, they just have 10 to the. It's the same thing. Any questions? I wanted to demonstrate how to use Chem 101 because you're going to have to put in your information on some of the problems. Some of them no, some of them yes. There are several conversions you can now do along with several of the problems. The only ones that we haven't discussed that I will be discussing on Friday, first thing, is what to do when you're dealing with cubed roots and what to do when you cannot start with something that has a single unit associated with it. When that happens, you'll have to start slightly different. And I will demonstrate those two before we move on Friday. I will hang out and answer questions, but otherwise I will see you on Friday, tomorrow in lab.